Imagine this. You're staring up at the night sky, a vast canvas of twinkling stars, and suddenly you realize that not everything up there is from our own cosmic backyard. Some visitors are wanderers from distant star systems, hurtling through our solar system like cosmic hitchhikers. Right now, in October 2025, we're in the middle of one of the most exciting chapters in space exploration history. Two incredible comets, one an interstellar stranger, the other a dazzling solar system native, are lighting up our telescopes and sparking wonder worldwide. The first is 3I/ATLAS, the third confirmed object from beyond our stars, zipping past Mars just days ago with a tail that's rewriting what we know about alien worlds. And then there's C/2025 R2, nicknamed SWAN, a brilliant comet that's bright enough to spot with binoculars, streaking across the evening sky like a feathery arrow from ancient myths. Why do these matter? Because they aren't just pretty lights. They're time capsules carrying secrets from the universe's earliest days, clues to how planets form, and reminders that we're not alone in the cosmic neighborhood. Stick with me as we dive deep into these interstellar intruders and solar system showstoppers, uncovering their stories, their science, and what they mean for the future of space exploration. By the end, you'll see the stars a little differently, I promise. Let's start at the beginning, with the discovery that set astronomers buzzing this summer. Picture a quiet night in chilly July 1st, 2025. The Atlas Survey Telescope, that's the Asteroid Terrestrial Impact Last Alert System, a network of robotic eyes scanning the skies for potential threats, picks up a faint smudge moving against the stars. At first, it looks like any other comet, but crunch the numbers and something clicks. This one's trajectory is hyperbolic, meaning it's not looping around our sun like a local comet would. It's barreling in from interstellar space at over 137,000 miles per hour, fast enough to cross from Jupiter's orbit to the sun in months. Named 3I/ATLAS after its discoverer and its interstellar status, the I stands for interstellar, and 3 because it's only the third we've ever spotted. This comet entered our solar system from the direction of Sagittarius, near the heart of the Milky Way. Fun fact, before Atlas caught it, pre-covery images from other telescopes traced it back to mid-May, showing it was already active, puffing out gas and dust even at 4.5 times Earth's distance from the sun. That's like finding a firework that's been smoldering for millions of years before it finally ignites. What makes 3I/ATLAS so special isn't just its speed or origin. It's a genuine interstellar comet, complete with the icy nucleus and glowing coma that define these frozen wanderers. Unlike the first interstellar visitor, Oumuamua in 2017, which was cigar-shaped and mysteriously dry, or 2I/Borisov in 2019, which gushed carbon monoxide like a boozy breath, 3I/ATLAS is alive with water. NASA's Swift Observatory clocked it, losing water vapor at a staggering 40 kilograms per second in July and August. That's like a fire hose on full blast, spraying enough to fill an Olympic swimming pool every few minutes. At that distance from the sun, where temperatures hover around minus 200 degrees Fahrenheit, you'd expect the ice to stay locked up tight. But nope, at least 8% of its surface is erupting, probably from tiny icy grains in the coma acting like mini geysers. This high activity rate dwarfs the 3% to 5% we see in most solar system comets, hinting that 3I/ATLAS formed in a colder, more volatile-rich environment around another star. And get this, the James Webb Space Telescope, our infrared powerhouse, peered at it on August 6th and found a carbon dioxide-dominated coma with a CO2 to water ratio of 8 to 1, one of the highest ever measured. That's not just chemistry. It's a snapshot of a protoplanetary disk billions of years ago, perhaps from a metal-poor star system where ices froze out far from the frost line. As 3I/ATLAS hurtles inward, it's putting on a show for our best instruments. The Hubble Space Telescope snapped it on July 21st, revealing a teardrop-shaped dust cocoon around a nucleus no bigger than 3.5 miles across, possibly as small as half a kilometer, shrouded in a reddish haze from organic tholins. those tar-like compounds that paint distant asteroids. By late August, a fan-shaped dust plume stretched westward, brighter on the sun-facing side, while an anti-solar tail ballooned to over 50 arcseconds long, pushed by solar radiation on micron-sized grains. Ground-based scopes like the Very Large Telescope in Chile detected cyanide gas and even atomic nickel vapor. Yes, nickel, evaporating at rates up to 4.6 grams per second without a trace of iron, which is weirdly unusual for comets. No carbon chains like C2 or C3 showed up either, suggesting this comet's missing some of the building blocks we take for granted in our own icy relics. And the polarization? Extreme negative values at small phase angles, like it's wrapped in a mix of fluffy ice and dark dust, echoing trans-Neptunian objects from our Kuiper belt. On October 3rd, it zipped within 29 million kilometers of Mars, close enough for the Perseverance rover and Mars Reconnaissance Orbiter to image its faint glow, a 5-second snapshot from ExoMars' camera, marking the first time we've seen an interstellar object from another world's perspective. Now let's compare this to its predecessors, because each interstellar visitor teaches us something wildly different about the universe's diversity. Oumuamua was the oddball, reddish, tumbling, no coma, accelerating non-gravitationally in ways that sparked wild theories from solar sails to alien tech, but ultimately explained by outgassing of trapped ices. Borisov, on the other hand, was a classic comet, but juiced with 20 times more CO than ours, like it brewed in a star system with a hot Jupiter stirring up volatiles. 3I/ATLAS question mark. It's the water wizard leaking H2O and OH radicals where we least expected, with that CO2 punch suggesting it hails from the outer fringes of its birth disk, maybe 7 to 14 billion years old if it's from the Milky Way's thick disk, older than our entire solar system. Orbital stats back this up. Eccentricity of 6.14, inclination nearly retrograde at 175 degrees, and a hyperbolic excess speed of 58 kilometers per second, faster than its siblings. It's not bound to our sun. It'll sling past perihelion on October 29th at 1.36 astronomical units, just inside Mars' orbit, then wave goodbye to Earth at 1.8 astronomical units in December before heading out toward the stars. These three objects alone upend models of interstellar populations. We thought they'd mostly come from the solar apex, but 3I/ATLAS arrived from the galactic south, challenging our predictions and bumping estimates of how many such wanderers zip through every year. Shifting gears to the other headliner stealing the show this fall. C/2025 R2, or SWAN, a long-period comet that's anything but shy. Discovered just a month ago, on September 11th, by amateur astronomer Vladimir Bazugli, sifting through images from SOHO's SWAN instrument. That's the Solar Wind Anisotropies camera on the Solar and Heliospheric Observatory. This one's a solar system native, but with interstellar flair in its dramatic entrance. Pre-covery shots pushed its first sighting back to August 13th, when it was already a magnitude 11 faintling in Virgo. By mid-September, it exploded in brightness, peaking at 5.9 after an outburst, and now at magnitude 6.7, it's gracing the evening sky low in the west after sunset, about 10 degrees above Antares for northern viewers. Perfect for 50mm binoculars if you catch it before twilight swallows it. Southern Hemisphere folks got the best seats early on, with its tail stretching 2 degrees like a cosmic feather duster. SWAN hit perihelion on September 12th at a scorching 0.5 astronomical units from the sun, closer than Mercury's average, which explains the surge, solar heat vaporizing ices into that glowing coma and tail. Its orbit, eccentricity near 1 at 0.993, a 654-year loop that takes it out to 150 astronomical units at aphelion around 2,336, making it a visitor from the Oort cloud's fringes, dynamically old and scattered by passing stars eons ago. What sets SWAN apart in this comet season isn't just its timing, it's the spectacle amid a parade of sky events. As 3I/ATLAS plays the subtle explorer, SWAN's the rock star, potentially dipping to magnitude 4 by its Earth flyby on October 20th at 39 million kilometers. About Venus distance, safe but spectacular. Its tail, broad and anti-solar, points away from the sun thanks to radiation pressure on dust grains. And on October 6th, Earth might graze its meteoroid stream for a faint shower, though the particles are too spread out for a meteor storm. Fun analogy: if comets are the solar system's dirty snowballs, Swan's the one that rolled downhill and picked up glitter. Its coma diameter hits 6 magnitudes brighter than the nucleus alone, a hazy envelope of gas and dust lit by sunlight. And get this, it's crossing paths with another bright comet, C/2025 A6 Lemon, both greenish from diatomic carbon emissions, turning October skies into a dual comet show not seen since 2004's Bradfield and Neat. For space enthusiasts, it's a reminder that our own backyard holds endless surprises, even as interstellar guests remind us how vast the neighborhood is. These discoveries aren't isolated fireworks. They're threads in the tapestry of modern space exploration, weaving together ground-based grit, orbital sentinels, and flagship telescopes into a global effort. Amateur astronomers like Bazugli kick it off, spotting SWAN in SOHO data that pros might overlook, while pros rally the big guns, Hubble, Webb, VLT, for 3I/ATLAS, coordinating observations from Lowell to Gemini South. Missions in flight join the party. Parker's diving sunward, Juno's eyeing a potential Jupiter intercept, and JUICE from ESA will catch 3I post-perihelion in November, with ultraviolet specs for sulfur ratios and gas mixes. Even rovers on Mars contributed, with Perseverance's cameras framing the interstellar speck against rusty dunes. This synergy? It's democracy in action. Backyard scopes to billion-dollar orbiters, all chasing the same thrill. Data pours in, SphereX mapping the CO2 coma at 348,000 kilometers wide, swift tracing water loss, polarimeters revealing dust textures like cosmic fingerprints. It's not just data, it's collaboration across borders, from Chile's Atacama to Hawaii's Mauna Kea, proving space exploration thrives on shared curiosity. Peering deeper, these comets challenge and expand our understanding of planetary birth. Take 3I/ATLAS's CO2 overload and carbon chain drought. It suggests a parent star with low metallicity, maybe 40% of our sun's heavy elements, where volatiles like water and CO froze into planetesimals without the organic soup we see here. That's huge for exoplanet hunters. If interstellar comets carry water, the key ingredient for life, across the galaxy, then habitable worlds might be more common than we thought. SWAN, meanwhile, embodies Oort cloud dynamics, its old orbit perturbed by galactic tides or rogue planets, hinting at how our distant reservoir feeds the inner solar system with fresh ices every few centuries. Together they bracket the spectrum, one alien relic, one homegrown, both outgassing volatiles that could seed atmospheres or oceans. Theoretical models now predict thousands of such visitors yearly, but detecting them requires faster surveys like the Vera C. Rubin Observatory, which serendipitously imaged 3I/ATLAS pre-discovery. And whispers of Avi Loeb's fringe ideas? Sure, he floated tech probe theories early on, but evidence, coma, tail, ices, solidly pegs it as natural, a pristine fossil from cosmic noon. As these comets fade from view, 3I/ATLAS, vanishing behind the sun until December, SWAN dimming post-flyby, their legacy lingers in the questions they ignite. What other secrets hide in their ices? Could 3I/ATLAS's nickel vapors point to exotic weathering on its homeworld? Will SWAN's stream spark a surprise meteor burst? And broader, in a universe teeming with stars, how many more interstellar envoys await, carrying blueprints of lost worlds? These aren't just flybys, they're invitations to dream bigger, to push missions like Europa Clipper or Dragonfly toward icy frontiers, and to build the next generation of scopes that catch the faint glows we once missed. So there you have it, The thrilling saga of three I/ATLAS and SWAN, two comets colliding with our skies and stirring the soul of space exploration. From water-spraying fire hoses to binocular bright tails, they've shown us the universe is alive, dynamic, and full of surprises. Key takeaways? Interstellar objects like 3 I/ATLAS prove our solar system's a busy highway, while locals like SWAN remind us beauty blooms close to home. They underscore water's ubiquity, challenge formation theories, and fuel the hunt for life beyond Earth. What do you think? Will we spot a fourth interstellar visitor before 2030? Or spot SWAN yourself tonight and share your view? Drop a comment below with your stargazing stories. Hit that like button if this sparked your cosmic curiosity, and subscribe for more dives into the stars. We've got Mars updates and black hole breakdowns coming next. Check out our playlist on recent space discoveries for more. Thanks for joining the adventure. Now go look up. The universe is waiting.